Hello folks, welcome to CodeCrucks. In this video, we will discuss an example on equivalence of DFA. In previous video, we have discussed the algorithm for constructing the combined machine. If you don't know how to do it, then I suggest to watch the previous video. The link of that video is given in description box. So this is the algorithm we have discussed, that we have to create the combined machine, and if every pair of Si, Qj in machine M3 are either final state or non-final state, then two machines M1 and M2 are identical, otherwise they are not. So let us understand it through the example. Assume we are given two machines M1 and M2 as shown here. So M1 is having a states Q1, Q2, Q3, and M2 is having states Q4, Q5, Q6 and Q7. S0, that is the initial state of machine M1, is Q1, and Q0, that is the initial state of machine M2, that is Q4. F1, that is the final state of machine M1, is Q1, and F2, that is the set of final states of machine M2, is Q4. So from that we will build the combined machine and we will check the equivalency of these two automata. So one automata has 3 states, one has 4. And we have to check whether they are same or not. So the first step from the algorithm, we have to add initial states S0, Q0 to the machine M3. So here S0 is Q1 and Q0 is Q4. That is the S0 corresponds to initial state of M1, that is Q1. Q0 corresponds to initial state of machine M2, which is Q4. So Q1, Q4 we are adding into machine M3, and as we can see that Q1 is also final state, Q4 is also final state. So this combined state Q1, Q4 is also final state. So if one of the state in this combined machine is final in the original DFA, then we have to make that combined state as a final in M3. Now we have to explore this state. That is, we have to construct the delta transition of Q1 and Q4 for given sigma. So if we look at the M1 and M2, then these DFAs are constructed over alphabets C and D. So we will find out delta transition of Q1, Q4 on C and same on D. So delta 3, the combined state Q1, Q4 on C, we can rewrite it as a delta 1 Q1, C, comma delta 2 Q4, C. Because Q1 belongs to machine M1, so we will consider delta 1 transition on that. And Q4 belongs to machine M2, so we will apply delta 2 transition on that. But the input alphabet is C for both. So if we look at the M1, then on C, we are moving on the same state Q1 if we read C. And in machine M2, if we read C from Q4, we are remaining on to the same state Q4 itself. So this transition is giving Q1, Q4 itself. So we have to put self loop of C, that when we read C from this combined state, we are going to stay on the same state. Now we will explore it for the another input alphabet, that is D. So delta 3 of Q1, Q4 on D is given as, now we have to split it. So delta 1 on Q1D, comma delta 2 on Q4D. So let us look in M1. So when we read D from state Q1, then we are moving to state Q2, and in M2, if we read D from state Q4, then we are moving to state Q6. So Q2, Q6 is the new state generated from the M3. If we read symbol D from Q1, Q4, then it will lead us to new state D2, Q6. Neither D2 nor Q6 is final state in the original DFAs, so in M3 also it will not be the final state. Same process we have to repeat for the newly generated state Q2, Q6. So let us expand Q2, Q6 for input alphabet C and D. So when we read C from Q2, Q6, it will give us Q3, Q7. Fine. So Q2 is in M1. If we read C from Q2, it leads us to Q3 state. And Q6 is in M2. If we read C from Q6, then it leads us to the Q7 state. So when we read C from Q2, Q6 combined state in machine M3, it will lead us to Q3, Q7 state. Again, neither Q3 nor Q7 are final state in original machine. So this will also not be the final state. Same we have to find out for input alphabet D, and that gives us Q1, Q4. So from Q2, Q6, if we read D, then it will lead us to Q1, Q4 state. So Q1, Q4, Q2, Q6, these two are expanded. Now it's turn of Q3, Q7. We will expand that Q3, Q7. So we have to find out again the same things, delta 3 for Q3, Q7 on input C. That is leading us to Q2, Q5. So new state will be added for that. And if we read D from Q3, Q7, then it is remaining onto the same state. Right? So delta 1 Q3D and delta 2 Q7D we can verify in M1 and M2, which gives us Q3, Q7. So we have to add the self loop, because after reading D from this combined state, we are remaining onto the same state. Q2, Q5 is not yet expanded, so we will expand that. Okay? So next step is to expand Q2, Q5. When we read C from Q2, Q5, we are moving to Q3, Q7. So we will add arc like this on reading C from Q2, Q5. Now we will read D from this state. So delta 3 Q2, Q5D lead us to Q1, Q4. So we have to show the transition like this. Now all four states are already expanded, so our algorithm will hold here. Okay, expansion part is done. Now comes the checking part. Okay, all states in M3 are expanded, so stop here. Now we have to make sure whether these two are identical or not, or they are equivalent or not. So one by one we will pick up all the states and we will do the condition checking. As we can see in M3, the combined state Q1, Q4, both Q1 and Q4 are final states. Right? We can see that Q1 is final in M1 and Q4 is final in M2. So both are final state. If we look at the next state, that is Q2, Q6, so Q2 is non-final in M1, Q6 is non-final in M2, so both are non-final states. Next is Q3, Q7, so Q3 is non-final in M1, Q7 is non-final in M2, so both states are non-final states. And for Q2, Q5 also, Q2 is non-final in M1, Q5 is non-final in M2, so both states are non-final states. So as we discussed in the previous video, that if this condition is held for any state or any pair of a state Si, Qj, if both are in final or both are in non-final, then we can say that machine M1 and M2 are identical. So whatever language is generated by M1, same language we can generate by M2 as well. Okay, so L of M1 is equal to L of M2, and hence machine M1 and M2 for given case are equivalent. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.